Welcome to the 41st video in our series about Unix tools. In this video, I will show you how to write, compile, and run a C program that has multiple source files. But first, let's review what we learned in video 40. In video 40, we saw that for a single .c file, the process of creating and running the executable was simple. We compiled a .c source file into a .o object file. Then we linked the .o object file into an executable. And finally, we ran the executable. We also learned about the file command, which tells us what kind of data is stored in a file. If you have an extension to tell you, it's pretty easy. .c is a C language source file. .o is an object file. But for our file hello, it's ambiguous. We can look at the file permissions and see it's executable, but it's impossible to know from the extension what it is because it has no extension. So let's start there today. And if we double check with pwd, yes, I'm in the CLAN directory, and you can see if I type this correctly, I've got the files and the history in the what I did, plus I've got the hello C source file, the hello object file, and the hello executable, which has executable permissions and will run and display hello BUU. Today, I said I would show you how to compile multiple source files to create an executable. Normally, if you're not doing a toy example from class, most significant applications written in C use more than one file of source code, and they also use header files. So let's get started. We can remove the old executable because we're going to replace it. We can remove the old object because we're going to have to recompile because of changes in how our program is structured. And if we look with ls instead of dir, I've been using Windows too much. With ls, you can see I've got my C language source file that has main in it, and I've got the history of actions we've done before. So let's look at hello.c, and you could say, well, the first step would be, instead of calling printf, I'd call something that says greet. Okay, it would call greet. And that's what we would do. And you can see there is no greet in this file, so we're going to have to include some header file so we can find it. And it's probably in a file called greet, but maybe that's too confusing with a function and a file with the same name. So let's call it something else instead, and let's say helpers. Because it has the single header file from the user, and we know it's from the user because it has double quotes instead of greater than, less than symbols. That means we're going to have to create the helpers file and put some sort of definition of greet in there. So let's save this, the modified buffer, and let's create another file, helpers.h, and in this file that is a very traditional sort of structure which you'd learn about in your C language class to prevent including the same header file twice. And then we need to give some definition. Since greet is not going to return anything, it's a void, and it doesn't take any argument. And so there, we've defined what the parameters are, the name, greet, and we said it doesn't return anything. So we're done with that. And we're going to put that in helpers.h. And if we cat hello.c, it used helpers.h. At this point, we should be able to compile hello.c even though we don't have helpers.c yet. I say we should be able to do it. Let's see if we can. Yes, the definition is in the header file. The actual implementation is not. So we need to create another file, helpers.c, that's going to include the definition of the code, the body of greet. We have the signature of that function in helpers.h, but we don't have the actual code. So what do we have to do? This is going to have to include helpers.h. We need to do that to make sure that the function we define matches the function we declared in the helpers. And if you remember, it was greet. So that should look the same, but now we're going to actually do something in here, which is printf hello BUU. And when you look at this, you say, wait a minute, I want to do a printf. Printf is going to require standard I/O from the system. Okay, we've put in everything we think we need. We're going to save it. And then we need to go back and ask ourselves about that hello.c again and say, wait a minute, because we use greet, we don't have any standard I/O anymore. We need standard lib for exit success, but we don't need standard I/O in here. So we can get rid of that. And of course you want the minimum set of headers that still works. So we save that. And you may be confused right now. We're going to remove the object, we're going to clear the screen, and we're going to say, what have I got? I've got hello.c, which has the main. I've got helpers.c and helpers.h. And if I look at each one of those, maybe we'll use a glob, and you could see, okay, here's all the stuff, but we didn't really get any kind of name from those, which is confusing. But here's all the code we're going to use, and we'll do them one at a time to make it easier. Helpers.h. It's a header file. It defines the function signature for greet. Helpers.c. That actually has the code for the greet function. And then in hello.c, that has our main, which has the call to greet, and it can do that because it has the definition from helpers.h up here. Okay. Think back to the previous video. Let's do what we always do. We compile. So we're going to compile the hello.c to hello.o. And we have another C file this time. We have helpers.c, and we're going to call that helpers.o. So now we have two object files, and the link is pretty simple. You do a GCC, and then we need the object files, and we give an output of hello. And when we run it, it works. So hello application is made of hello.o and helpers.o objects. And in another video, I'll show you how to investigate what's inside the object files, but we're out of time on this video. We did succeed. Our mission was to create an application that uses multiple C files, and we did. Thank you for listening.